So, we are looking into the design and selecting of a suitable insulator. So, for 220 kV system, so as mentioned we have the following parameters which we have got, the leakage distance being 170 inches, the switching surge or a switching impulse voltage will be 850 kV, and the lightning impulse withstand value will be 1056 kV. These are all for the dry conditions, that is for the normal conditions in the insulator strings or in the outdoor environment, that is without considering the rain, fog or pollution conditions. In case of pollution, rain or fog, the wet flashover voltages or the wet switching surge, lightning impulse and the values gets changed. So, that we will be discussing. So, this whatever approximate values which we have are shown here for 220. Similarly, for 66 kV the table shows you, in case 66 kV the maximum system voltage will be 69 kV and the line to ground will be around 41.8 and line to ground voltage into root 2 will be 59.1. And here again for 69 kV if you take the insulator strings are operating at different environments, we see leakage distance being at 41.8 and switching surge voltages 125 kV and lightning surge voltages being at 359 kV. So, these are the two different values for different voltage levels. Similarly, for higher the voltages 400 kV 765 and higher voltages, a similar pattern will be followed with other considerations for the design aspect. So, just looking into the approximate values, the approximate values which we have obtained for both the voltage levels are shown here, the 66 and 220 kV, the leakage distance being 41.6 in case of 66 kV and 220 kV it is 170. Switching surge voltages being 125 kV in case of 66 and 850 and lightning impulses 359 and 1056. As I mentioned these values are for dry conditions. So, now the selection whatever we have made or we have seen are from the data for the 66 kV. You know the leakage distance when you look, the required is 42 inches. So, the available from the manufacturer is 46 inches. So, which is higher than the required which we have tried to estimate. Similarly, in case of impulse voltage levels, we have 125 kV and the available is 240 kV for wet switching surge, and impulse withstand voltages the required is 359 as per our calculations, the available is 374 kV. So, these voltage values by the manufacturers which are available are higher than the values which have been estimated. So, similarly for mechanical and electrical strengths, the mechanical strength requirement is 12,000 pounds, whereas available mechanical strength with the insulator from the manufacturer is 15,000 pounds. So, various contaminated environments I was mentioning you in case of wet or polluted conditions. So, polluted conditions are again divided into various zones like light, medium, heavy, very light and so on. So, these areas where the insulator strings are to be used are being taken care particularly depending upon the area of the polluted zones. So, for this term known as ESDD is equivalent salt deposit density. This is given in milligrams per centimeter square. This equivalent salt deposit density depending upon the site severity, I was telling the location where the insulator strings are to be connected or the towers which are to be erected, depends upon the leakage distance which is to be considered. That is, I is the suspension string, I was mentioning you for a configuration of suspension string, V being the V type of string. So, here it will be inches per kV the values for line to ground voltages. So, you can see that ESDD is nothing but the equivalent salt deposit density on the surface of the insulator. How it is calculated? So, normally the insulator is allowed to be in the field for a certain period of time based on the site severity, whether the area is light, moderate or heavy polluted zone. The insulator after period of time is taken out, and the ceramic or a porcelain portion, except the cap and pin, the contents or contaminants which are spread on the only insulating surface are removed carefully with a known quantity of distilled water, and the conductivity is measured, and this is how we see the equivalent salt deposit density on the surface of insulators. So, based on this data, we can say that the line which is being erected comes under pollution of light, medium or heavy polluted zones. So, this is the application, there is application guide particularly how to be used during the insulation design. There are standard and also the international bodies which have the data for this. Similarly, important IEC International Electrotechnical Commission standard 60815 which completely gives about the information on the polluted conditions, the values which are to be used for the simulation in the laboratory for a particular kV voltage level is described in standard 60815 for various type of insulators depending upon the creepage length of the insulator, how the insulator can perform in these conditions. So, the criteria has been given and various values as per the standard specified values of ESDD, that is equivalent salt deposit density, are to be used in case in the laboratory verification or laboratory testing of this insulator for various types of insulators to be tested. So, again the recommended leakage distance, various groups, this includes the IEEE International Study Groups and IEC is the International Electrotechnical Commission. Apart from there are several other standard bodies which converge and they look into these requirements for various leakage distance, and they have recommended. So, these are the curves which show for the recommendation of the leakage distances in inch per kV, that is a line to ground, versus the equivalent salt deposit density, that is in milligrams per centimeter square. The values have been defined for various pollution zones. So, both for ceramic, glass and polymeric materials which have to be used for the laboratory evaluation for the verification of performance of insulators. Then again this graph shows the improved contamination performance, mainly gives about the flash hour versus the equivalent salt deposit density, the flash hour voltage across the equivalent salt deposit density. The curves very clearly give you the idea which are been used for porcelain, then EPDM and polymer insulator. There is a new SRS silicon rubber insulator, aged silicon rubber insulator. Ethylene poly-di monomer is the EPDM material which is being used for the insulation purpose. So, this gives you the improved contamination performance, the measure of equivalent salt deposit density, how it is being used in the field with the help of the pollution monitors, using a dummy insulators in service, removing in service insulators, evaluation of the equivalent salt deposit density, and the selecting of the appropriate leakage distances to be used in that areas. So, very important graph which gives you the idea for the improved contamination performance. So, the contamination or the pollution performance of an insulator is a very important issue when you go for extra high voltage and ultra high voltage transmission I was mentioning. Now for last 100 years we were using the polymer porcelain or the ceramic insulators and the glass insulators. Polymer insulators, as I was mentioning, it is of the recent origin, and particularly they are organic in nature. So, polymer insulators presently what we have seen offer better contamination flashover performance than porcelain. Yes, but again the performance has to be judged over a period of time. These insulators being of recent origin, the field data available for the longer performance, a longer time performance is not yet available. So, we have to see the performance over a period of time and then conclude that polymer insulator can offer better performance for a very long period of time. Yes, short term performance they are performing good and giving the better contamination flashover performance in comparison to the porcelain or glass type of insulators. The polymer insulators or silicon rubber or a composite insulator have smaller core, that is a fiberglass core and weather shed diameter, there is a petticoats which the molded on the fiberglass rod. This can increase the leakage current density. So, it is a important comparison compared to the porcelain. Looks aesthetically much better than the earlier porcelain or a glass type of insulators. Higher leakage current density, what we were looking here means more ohmic heating. Again, more ohmic heating helps to dry the contaminated layer and reduce the leakage current. So, this is one of the very important aspect when using in for polymer type of insulator, where hydrophobicity, the property of the surface of the polymer insulator, try to repel the water and sees that it has better leakage current density and sees that the contamination layer and the reducing of the leakage current, which helps in the better performance of the flashover, particularly in pollution or contaminated areas. In addition, the polymer insulators, hydrophobicity helps to minimize the filming. Hydrophobicity is property of the surface of the material, where it tries to repel the water droplets or the polluted droplets which are being on the surface, particularly the water droplets, and sees that the filming formation on the surface is reduced, and where the contaminants or the pollutants goes on accumulating gets reduced. That is one more advantage with the polymer type of insulator. So, contamination performance of a composite or a polymer or a silicon rubber insulator exceeds that of their porcelain or a glass counterparts which are being used for a long period of time. This is an important point to be noted. The next being the contamination flashover performance, whether it exceeds that of the EPDM units. Again, depending upon the number of years the insulator is in service in comparison to the ethylene propylene monomer type of units, which were the earlier version of the silicon rubber insulators presently being used. Presently I mentioned that being used are of third generation. So, EPDM were earlier used, how much is better, the time comparison is very important. This has to be properly verified in the laboratory from the field insulators and can be judged the performance of the silicon with the information where the flashover performance could be better in comparison to the earlier EPDM units. Next, the grading rings, as I was mentioning, corona control rings, grading rings, arcing horns, these are all the similar names or are the same hardware which are being used for proper grading, that is the voltage distribution in case of various insulator strings. So, these grading rings, corona control rings are very important. They simulate a larger or more spherical object. In case as the voltage level goes up, the corona control rings of an spherical nature or a rectangular type which are being used in a long transmission insulators, long transmission lines and high voltage and extra high voltage and ultra high voltage transmission for insulator strings. These help in reducing the gradients, particularly associated with the shielded object. So, the insulator string is having a hardware, as I mentioned, the yoke plate along with several accessories which are connected to the tower side and also to the line side. So these have to be equally reduced so that the insulator never sees stress in a particular region. So the equal uniform distribution of voltage is to be maintained, and the higher gradients have to be reduced. For this, the grading rings or the corona control rings are employed for the transmission line insulator strings. So reduction in gradings helps to minimize the RIV and TVA. RIV is the radio interference voltage and TVI is the television voltage interference. So we will be discussing about the radio interference voltage and TVI in future when we come to the importance of these parameters. So the gradients which in case if it is not reduced can lead to discharges from the particularly hardware and corona control or grading rings, and these discharges which are of impulsive in nature will communicate through the conductors and to the neighboring areas where radio sets or a television could be affected, because these are high impulse in nature and operate at that voltage levels. So radio interference voltage measurements which are carried in the laboratory see that the gradients are quite lower, and the discharges which are being from the hardware and grading rings do not interfere in radio interference radio circuitry or the television interferences causing interference to the radio and television sets. So mentioning about the porcelain or glass, these are inorganic and break down very slowly, which are being used for last 100 years or so. Mechanically they are good, and performance it has been judged over a period of time. Now the recent non-ceramic insulators are polymer, silicon rubber or composite insulators are more susceptible to seasoning due to corona. So corona is again a phenomena which happens near the hardware, corona control rings, particularly in the vicinity of high voltage where the discharges the air breakdown takes place, and the corona may be initially audible, then the visible discharges coming out from the hardware or a corona control rings or a grading rings continuously impinge on the surface of the particularly non-ceramic insulator or polymer insulators over a period of time, which in the intensity is more, may cause the insulator surface to lose its hydrophobicity, and likely over a period can reduce the surface properties, insulating properties. This how it happens due to the corona. We will be also discussing about the effect of corona on the polymer insulators and how it could affect the insulation in future. So next, the UV ultraviolet, again these are short wavelength range. This may attack the polymer bonds on the silicon rubber or polymer insulators. See, this ultraviolet again may be from the natural sun during the daytime or due to the corona. The effect of corona also causes the ultraviolet radiations which may impinge on the surface and attack the polymer bonds, making the surface of the insulator less hydrophobic, and where the surface may degrade over a period of time and the insulation level could be reduced. So the most short wavelength ultraviolet is filtered by the environment, but the ultraviolets which is coming from the corona is not filtered and it may damage the surface. So ultraviolet due to corona is not filtered. This ultraviolet due to corona is from the hardware, corona control rings or grading rings. So non-ceramic insulators have a different corona control rings which are designed not like the porcelain or a glass type of insulator. So here the design of the grading rings or the corona control rings depends on how the hardware end fittings of the non-ceramic insulators is designed and for the particular voltage level. So, due to corona cutting what we call, and also water droplet corona, which this water droplet corona may happen because of the rain droplets which settle on the surface of a polymer insulator. So, these are likely to develop small discharges and later on corona discharges which slowly degrade the surface on the insulator, and the hydrophobicity effect could be over a period of time it may lose the hydrophobicity characteristics, later on the degradation of the insulator could happen. So, the non-ceramic insulators may require the application of the corona control or a grading rings, particularly to grade the field on the polymer material on the weather shed housing. So, this is very important. In case proper design of corona control rings for the non-ceramic or a polymer insulator is not done, the material could the weathering on the particularly on the weather sheds, the petticoats or the weather shed of the material could lose the hydrophobicity over a period of time. So, these corona rings must be, or grading rings must be properly positioned. The positioning of the corona control rings is equally important with the design. So, not only the design plays a role, the positioning of the corona control ring, alignment in the string is very important, so that the end fitting on which they are mounted has to be properly mounted, else there could be shift in the position, and this may lead to higher corona discharges which may damage the surface of the polymer sheds. So, the orientation positioning is to provide grading to the polymer material or a polymer insulator string. As a general rule, the corona control rings or the grading ring should be over the polymer brackets which should be on the hardware. So, these brackets or accessories are provided on the insulator metal end fittings which are connected to the tower. So, they should be properly positioned, properly mounted and properly oriented with the help of brackets on the hardware, that is on the yoke plate or the connecting hardware to the tower and to the conductor side. So, what is the service experience which has been observed over a period of time? So, we will discuss about for both the ceramic and the polymer insulators which have served the transmission system for a period of time. What are the likely problems or issues which could happen in case of a polymer insulator, a porcelain insulator or a glass insulator? We will be discussing the particular issues in the field related failures and so on. The ceramic or a porcelain, I was mentioning they are more than 100 years old, initially started off as a telegraphic insulators were employed for the transmission very early stages, and presently the porcelain or ceramic insulators are used for all voltages from a very low voltage to the ultra high voltage range up to 800 kV or even for the 1200 kV experimental lines. The porcelain insulators are being used for the line insulation. These provide porcelain insulators provide greater flexibility because they have a cap and a pin arrangement. This is the cap, this is the pin of the insulator, this is the porcelain shell, and these are the petticoats, the sheds what we call. So, the cap and pin are connected or fixed to the porcelain shell with the help of a Portland cement, and properly the zinc coating is carried out to see the corrosion never happens in the field. So, a schematic of the design of a porcelain suspension insulator is also shown here, where the porcelain shell is this one, and the cap, whatever the cap which you see is the malleable or a ductile iron material which is fixed on the as a cap of the insulator. And we have a pin is again a malleable and forged iron pin. This is a iron, both are iron cap and pin of the insulator. These are fixed with the help of a Portland cement with a bituminous coating here. So, you have initially a sand band particularly here to fix the pin and also to fix the cap. A sand band is coated fixed to the surface of the porcelain disc. Later on, with the help of the Portland cement, both the pin and the cap of the insulator are fixed, leaving a small cushioning with here to the insulator. So, this is how the ceramic insulator is designed for the transmission system. So, this as mentioning used for last 100 years, and they are used for all voltages for any type of line insulation, and they provide greater flexibility because of this cap and pin arrangement, and they are strong in compression, particularly because of the compressive loads, because of the wind variation, because of in the tension. They are very good at compression. That is one of the advantages of using a ceramic insulators. They can take better compressive load in comparison to other insulation. So, they are available in various shapes. Again, the shape, it depends on where the area this insulator is being used, either it is for a normal conditions, that is a clear conditions, or a polluted zones, or the desert areas. So, depending upon the areas, the petticoats can be designed and the shapes can be made available. So, this is very simple to make it, and complicated sometimes, because you require a special petticoat for a particular area in case there is a fog. So, the anti-fog type of insulation has to be done, and it has to be carried out with a high degree of standardization, including the material aspect and the process. So, this is how the porcelain or a ceramic insulators are being serving the transmission utilities. So, what is the experience with ceramic? Electrically, over a period of time, that is more than 100 years, they have said. Electrically, they are fairly stable with time, over a period of time. Mechanically, they are subject to deterioration with time. Mechanically, they could happen there may be a cement issues here, the corrosion on the pin, there could be a problem with the cap. So, this is because of the mechanical load, because of the environmental factors, the corrosion of the pin could happen, and in some of the cases where the cap and pin gets detached from the insulator, it leaves the line detached to the tower.